Welcome to the ninth part of our interview series. Stephen, your detailed insights into the potential technologies used in your harassment are fascinating. Can you tell us more about your experiences and any ideas you have regarding the different RF characteristics of the systems you've encountered?
Absolutely, Joanna. From my experiences, it seems the offenders use different technologies. Here at EuroTMS, what ya EuroTMV gathered about conventional radar, Wi-Fi/microwaves, and magnetic pulses. But I'm not an expert, so I'll let Ruth and Brian explain the technical details.
Thank you, Stephen. Ruth and Brian, can you explain the RF characteristics of these different systems and how they compare?
Certainly. Let's start with a comparison of conventional radar, Wi-Fi/microwaves, and magnetic pulses. Conventional radar, traditional radar systems use sinusoidal carrier waves modulated with specific envelope shapes, which dictate pulse duration, repetition rate, and encoding schema. These systems utilize amplitude, phase, or frequency shift keying to encode information. Recipients extract timing, location, velocity, and other parameters via correlation, triangulation, or statistical techniques. Wi-Fi/microwaves, wireless networking standards like Wi-Fi use carrier frequencies centered around ISM bands, industrial, scientific, medical. Digital modulation schemes, such as quadrature amplitude modulation, QAM, vestigial sideband, VSB, or orthogonal frequency division multiplexing, OFDM, superimpose information symbols onto carriers, conveying bits over wireless links. Bandwidth restrictions, duty cycle limits, and dynamic frequency selection protocols manage congestion, promote fairness, and prevent code-channel interference. Magnetic pulses, unlike the above paradigms, magnetic pulse radar, MPR, relies on fleeting magnetic flux reversals to probe the immediate vicinity. Rapidly fluctuating magnetic fields induce eddy current flow within conducting targets, yielding secondary electromagnetic radiation proportional to material composition and geometric extent. Extracting diagnostic information requires sophisticated signal processing, considering the brevity and minuscule intensity of return signals.
The differences among these technologies impact their effectiveness and use cases significantly. Conventional radar offers detailed tracking and location information with broad applications in aviation, weather monitoring, and defense. Wi-Fi/microwaves provide high-speed data transmission for communication networks, with widespread use in consumer electronics, industrial automation, and medical devices. Magnetic pulses excel in non-destructive evaluations and subsurface imaging due to their sensitivity to subtle disturbances. MPR is particularly effective for probing material properties and detecting hidden structures.
How do these differences affect the technology's application in harassment?
Understanding these RF characteristics helps in devising effective countermeasures. For instance, conventional radar's broad applications and periodic signals make it predictable and manageable. Wi-Fi and microwave systems are ubiquitous but can be mitigated through network management and shielding. Magnetic pulse systems, however, require specific shielding techniques due to their unique way of probing materials.
Stephen, how has this knowledge from Ruth and Brian influenced your approach to defending yourself?
This knowledge has been incredibly helpful, Joanna. Knowing the strengths and weaknesses of these technologies allows me to focus on the right countermeasures. For example, understanding that magnetic pulses have limited spectral content and short dwell periods helps me focus on shielding techniques that can mitigate their impact.
Your technical expertise and resilience are truly inspiring. By sharing your insights, you're providing valuable knowledge that can help others facing similar challenges.
In this ninth part of our series, we've explored the distinct RF characteristics of various signal modalities and how they compare. Stay tuned for the next part, where we will discuss potential defensive strategies and support systems for those affected by similar forms of harassment.
Stephen's story continues to highlight the multifaceted nature of technological harassment and the need for creative and methodical strategies to combat it. By continuing this series, we aim to provide a comprehensive understanding and foster a dialogue that can lead to meaningful change.